suppose that a cell phone has a demand given by, oh, that's really close there, P equals D of Q, that was called a hiccup, equals 195 minus 0.5 Q, and a related supply given by P equals S of Q, 0.75 Q, where Q is the quantity of the cell phone in thousands. If you can read part A, it says, find and interpret the x and y-intercepts for D. Well, how do you find an x-intercept? You make y 0. Well, what is our y here? That's our P. So we'll say x-intercept. We'll say 0 equals 195 minus 0.5 Q. So how do you solve for Q?
Subtract the 190, or move the 195 to the other side.
Yeah, through subtraction, you were right. Subtract 195 from both sides.
First thing you was x minus.
And divide by negative.
Yeah, we'll divide both sides by negative 0.5. So what is negative 195 divided by negative 0.5? You should get like 390. Because dividing by 0.5 is really multiplying by 2. So you should get 390. Can anyone interpret that for me? When the price is, when the price is 0, so when it's free, how many cell phones will sell? 390,000. So when the price is 0, when it's free, 390,000 cell phones will sell. It must be an iPhone, no one wants those. Let's do the y-intercept. How do you find a y-intercept?
Plug in 390 for Q.
No. If we put in 390 for Q, we're guaranteed to get 0 for P. Because that's what it means to be a function. Make Q 0. So remember, when finding it's going to be fun because it's off. Oh, that's an equals there, kids. Oh, geez. This is a lot harder than it looks, by the way. Oh, that's a 5 times, oh my gosh, 0. Yep, calibration at its awesomest. So P equals 195 minus 0.5 times 0. Why is one side okay, but not the other? That makes no sense. What do we get here? To find x and y-intercepts, to find an x-intercept, you make y 0. Correct. To find a y-intercept, you make x 0. The reason being is on the x-axis, every point on the x-axis has a y-coordinate of 0. So that's why you make the y 0 to find an x-intercept.
Find the x-intercept, so in order to okay, so it's so you want to find the x-intercept, make the y 0.
Correct.
And then you want to find the y-intercept, make the x 0, and then I guess you divide by both sides or whatever.
Well, after you make them 0, whatever you do to solve it. So here we had to subtract 195 and then divide. Here we don't have to do anything because what's 0.5 times 0? 0. So we'll have 195 minus 0 is 195. Right. So trust me, this is saying 195. So what's the interpretation? When Q is 0, how many cell phones are selling? None. When Q, because Q is the quantity. So when the quantity is 0, that means the corresponding price is $195. So you will sell 390,000 cell phones if you make it free, or you will sell none of them if you make it $195. That's what that says. That's not how it's written, because again, oops. B, find the demand at a price of 100 and 150. So which of the two are you going to use, your supply or demand functions, he wonders. Good. So we're going to use P equals 195 minus 0.5Q. And we have two parts here, 100 and 150. Let's start with 100. Where do I put this 100? Well, it says find the demand when the price is 100. So where do I put the 100? P. So now it's like the X-intercept. We're going to solve for Q by doing what? Subtracting 195. And to save space there, I'm going to put implies. So we have negative 95 equals negative 0.5 Q. So how do you finish solving for Q? Yep, divide by negative 1/2, negative 0.5. So again, dividing by 1/2 essentially doubles it. So the double negatives will cancel. So what is 95 divided by 0.5? 190. So again, that says when you set the price to be $100, you're going to sell 190,000 cell phones. If you would, please do the same thing for 150. What do you end up getting for Q? 90. Why should an answer of 90 make sense? In other words, why should I have known that it's going to be smaller than 190? Because price went up. So as price went from 100 to 150, then the demand should have went down. So that's what's called an inverse relationship. As one goes up, the other one goes down. Whereas supply, as one goes up, the other goes up. So as we go from 100 to 150, the quantity should increase. So you're basically going to do the exact same thing that we just did for demand, except now you're going to use the supply function. So if you would put in the 100 in for P, I think you get a decimal here. For the sake of the problem, let's round to the nearest whole number, because fractional cell phones doesn't make sense. Well, actually, it's in thousands. So we can go up, we can say 0.333 thousand if you want. Because I think you get 133. But again, that's in thousands, so it's really 133,333 cell phones. And we'll do the same thing for the 150. I think this one turns out nice. What do we have here? 200,000, very good. Fantastic.
So all the numbers you wrote is in thousands, 190,000.
All the quantities are in thousands.
All the quantities in thousands.
Yeah, all the quantities are in thousands. I lost my head for a second there. So all these are Qs. Those are all in thousands.
When we had 90, it's supposed to be really 90,000.
Right.
190 is really 90,000.
Correct. But these, the prices aren't in thousands, because that would be a really expensive cell phone. No. All right. We have two more parts on this, but let's talk about a little bit of theory here. Actually, let's go back to this number right here. I purposely picked 100 and 150 for both parts B and C. Notice when the price was 100, the demand was 190,000, but the producer only made 133,000. So what does that mean for the consumer?
It keeps consuming one.
Yeah, they want it because there's a shortage. Whereas when the price was 150, the demand was only 90,000 cell phones, but the supplier had 200,000 cell phones. They're trying to get rid of them. So they're basically giving them away with diapers and, you know, all these other minor purchases. So this is a surplus when the supplier has too much. Well, we can modify our graph for supply and demand now to include that information. I'm actually going to put it on the slide itself. Next. So let's try this one more time. So this was demand. This was supply. And there's price. The point at which supply and demand is called the equilibrium point. The equilibrium point where supply and demand are the same. Anything above this equilibrium point, as we discussed, is a surplus. Meaning the producer has too many. Anything below is a shortage. The producer does not have enough. So notice in part D there it says, find the equilibrium price and quantity for the cell phone. So again, equilibrium is when supply equals demand. So what is our supply for this problem? It's right up there. Yeah. And our demand? So to find the equilibrium price and quantity, the equilibrium point, just set supply equal to demand and solve for Q. This time we'll move the 0.5 Q to the other side to get the Q's together. How many Q's will that make? Careful. Yep. And then finish solving for Q by dividing by 1.25. I don't know if it's a pretty number. Oh, I got 156. Did anyone else get that? Yeah. Well, this is the equilibrium quantity, because that's Q. So how do we find the equilibrium price? Into Yeah, you can pick either of them. Because that's the whole purpose, is we found them to be the same. So let's do the 0.75Q equilibrium price. Oh, that's not annoying. What is 0.75 times 156? 117. All right, now we're at where I wanted to say this. The 117 answer should make sense because when we sold it for $100, we had a short surplus, and we had it for $150. We had a shortage. I forgot which one it was now. I probably should have memorized that. So halfway between them should have been the equilibrium, is what I'm trying to get at. And 117 is between 100 and 150. So when they sell it for $117, they'll sell 156,000 cell phones. Huzzah. Questions?